question 9 is the last question, and it's about foreign aid. So, NG, an IR major, is writing his master's thesis on aid given to foreign governments by the World Bank. He finds a sample of donations given to various countries over the last decade and collects these findings in a table called Aid. Here are the first few rows. The table contains 4 columns, the date, a recipient country, an amount of money, and the reason or purpose for it. So for parts A and B, assume NG is studying the average amount of aid given per donation. Part A. To get a sense of the data, NG first plots a histogram of the aid amount in his sample. He finds the empirical distribution of amount has an average of 3.5 something million and an SD of 1.121 million. The distribution of amount in his sample is approximately normal, not approximately normal, and there isn't enough information to answer this question. So, just based on a mean and an SD, it is impossible to figure out whether it's approximately normal, or if it is approximately normal. There are ways, however, to see if it is not approximately normal. For example, let's zoom in so we can draw. If we have a graph, a standard normal distribution looks like this, right, with a mean, and then it should have multiple SDs to the left and multiple to the right. Specifically, we know that 68% of data in 1 SD, 95% in 2 SD, and 99.7% in 3 SD. And in order for that to happen, you need to have data that reaches 1, 2, and 3 SDs away. So here, we know the minimum aid amount is 0, because you can't give someone like negative aid. So if 0 were less than 3 SDs away from the mean, then we can probably conclude that the data are not normal. However, if we divide 3.532 by 1.121, we'd get 1121240. We'd get like 3.15 SDs. So in this case, it's we cannot say that it's not normal based on this, because it is still possible, but we don't know that for sure. So we're going to say we don't know this, and we will conclude there isn't enough information, because we simply don't have enough. Okay, part B. Suppose NG wants to use his sample data to create a 95% confidence interval of the true average amount of aid. If the distribution of all donations has an SD of $1 million and the aid table contains 10,000 rows, can NG create a 95% confidence interval that has a width less than 25,000? So the process behind confidence intervals is that we want to take a bunch of bootstrap samples of the same size as the original sample. So our sample size is going to be 10,000, right? So then we can calculate the SD of sample means equals the SD of the original sample, so 1 million, divided by square root of 10,000, and that's actually going to give us $10,000. Okay, so we want a confidence interval where the width is less than $25,000, and our confidence level is 95%, so we need to go plus or minus 2 standard deviations from the mean. So that would mean that we have a width of 4 standard deviations, and 4 times $10,000 is $40,000, which is too wide for us. So our answer should be we are unable to make a thin confidence interval like that because our sample size is too small. If we were to increase the sample size or decrease our confidence level, then we could get a confidence interval with a width less than $25,000. Okay, part C. For the rest of the question, assume that NG has turned his attention to learning more about the purpose of aid. So, part C. As NG is combing through the dataset, he notices some countries in South Asia appear to have a disproportionate amount of aid with rail and manufacturing compared to others. He creates the following table, which displays the aid given to countries in the region with the following proportions. Okay, so according to the above distributions, what is the empirical total variation distance of aid between India and Bangladesh? So, let's see, we want India and Bangladesh, so these two columns. And the way we calculate TVD is that we take the absolute value of the differences between each category, we add these all up, and then we divide by 2. So what we have here is the absolute value of 0 minus 0.9 is 0.9, plus 0.4 minus 0.1 is 0.3, and then 0.6 minus 0.0 is 0.6. And remember, when we use TVD, we have to divide by 2, so our answer is going to be 0.9. So that's our answer. Okay, so part D. The World Bank claims the total variation distance of aid purpose between India and Bangladesh is 0.3. NG isn't sure if his empirical TVD is different from 0.3 just due to chance, but he thinks he can bootstrap it to get a better idea. So we have 0.9 here. We want to figure out if this is just because of chance, or if our sample is actually different, or if the World Bank is just wrong. So complete the code below to write a function purpose TVD that takes in a table with the same column labels as aid, which are date, recipient, amount, and purpose. And it takes in 2 country names, country A and country B, and computes the TVD between the 2 countries' purpose distributions. Okay, so let's scroll down. So def purpose TVD. So dist A, here dist is going to stand for distribution. So we want the distribution for country A. So we only want to find the aid packages that were given to country A. So we can do, and to do that we want to filter out a bunch of rows. So we can say table.where the recipient would be country A. So for example, if our country A is India here, we will only get the rows of the table where the recipient is India. And then, since we want to get the distribution of purposes, right, we want to group the data by purpose. So counts A equals dist A dot sort by purpose dot, and then we want the we want a column of the counts. So that would be, or let's make a little drawing of what we would get if we group by purpose. So what would happen is we would get something like table here. So we would have purpose, and then we would have a function called, or a column called count. And that would just be the number of packages that come from this purpose. So like rail, and then we can have like 5. And then manufacturing, right? We'd have, let's say, 3. So we want this column. We want the counts. So we can get the column called count, or it would be lowercase. Another way to do this would be column of 1, because the columns are indexed starting at 0. So the purpose column would have index 0, and count would have index 1. So either of these would work. So now we want to repeat the same process, but for country B. So we can say dist B equals table.where recipient equals country B. And then again, we want to group by purpose. Then count B, again we get the column count out of the table. Okay, now this return value, so we're given some code about the proportions. So we want to know like what percentage of all my aid packages came from rail or manufacturing or anything else. So we want to return, we'll leave this blank empty for now, but to calculate the TVD, we need to take the absolute difference between country A's and country B's proportions. So country A's proportions are stored in props A, and country B's proportions are stored in props B. So we can just subtract these. Either order, it doesn't matter because we're taking the absolute value, and then we're going to add up all those differences, the same way we did in part C, calculating the TVD. And then lastly, remember we need in TVD to multiply by 0.5, so that's what this blank here is, 0.5 times np.sum of absolute value of props A minus props B. So that's how we do TVD. Okay, next, complete the code to simulate 500 bootstrap samples where we bootstrap India and Bangladesh independently, so we do those separately. Compute the TVD between purpose of the aid received by India and Bangladesh, and store all the results in boot TVDs. You may assume that purpose TVD has been defined correctly. So purpose TVD is the function we just defined, so we're going to assume we did it right. Okay, so we want 500 bootstrap samples, so we're going to repeat this process 500 times. So for I in np.arrange 500. Okay, so now we have two of these tables, India and Bangladesh. So we want to filter out only the aid packages that go to India and Bangladesh here. So India equals aid.where the recipient is India. Then this one for Bangladesh is the same thing, but for Bangladesh. Okay, so India is now a table containing only the aid packages that went to India, and then Bangladesh is a table with only the aid packages that went to Bangladesh. So boot India, so boot means bootstrap. So to take a bootstrap sample, we have to sample, and remember we want to do with replacement is false or with replacement is true. And when we do a bootstrap sample, we want with replacement to be true. So we're going to do the same thing here. With replacement equals true. So now we have a bootstrap sample of India and Bangladesh's aid packages. So now boot table is it's going to be a table, as it says, and what we want here is to, or we see this append here. So we know that append is used in a couple cases. We can append to an array, but the thing is here, we don't have very many arrays really to append to. So we actually are going to use the other version of append, which is for tables. So the way it works is table1.append table2 will just basically just stack all the rows on top of each other. Okay, so boot table equals boot India dot append of boot Bangladesh. So now we have both of their bootstrapped aid packages on top of each other now. So new TVD is our test statistic now. So let's go back up to the previous page. Remember that purpose TVD takes in a table that has the same columns as aid. So that would be namely like the recipient, the amount, the purpose, and the date. And we have one of those tables, and that's called boot table. So we have new TBD equals, we want to call purpose TBD on boot table, and then we want country 1 and country 2. So country 1 is India, and country 2 is Bangladesh. Okay, and then boot TBDs. This name is familiar because it came from this array at the beginning. And so what we want to do is new TBD spat out a test statistic, and now we want to add that to our array. So we can say boot TBDs equals np.append of boot TBDs and then new TBD. And then that will give us a full array. Okay, part F. Finally, complete the code below to compute an approximate 95% confidence interval for the population TBD between purpose received by India and Bangladesh. So left should store the left endpoint, and right should store the right endpoint. So a 95% confidence interval will be between the 2.5th percentile and 97.5th percentile. So we want to call the percentile function. So we can say percentile, and so left is the left endpoint, so the smaller one, so 2.5, comma, boot TBDs, and then right is percentile of 95, comma, boot TBDs. Let's close the parentheses here. Okay. So suppose it turns out that the values left and right are 0.24 and 0.78 respectively. So the confidence interval in part F is 0.24 to 0.78. Suppose we test whether or not the World Bank actually followed its claims in distributing aid to India and Bangladesh, i.e. the TBD is actually 0.3. Using this confidence interval and a 5% cutoff for the p-value, pick all the correct ways to complete the sentence. So notice that 5% cutoff for the p-value is really convenient because we have a 95% confidence interval. Remember that to get an X% cutoff, we want a, let's write this down, to get X% p-val cutoff, you want a 100 minus X% confidence interval, which is nice because we have a 95%. Okay, so your claims are the same. So this could be true, but unfortunately we don't know that for sure. So just because 0.3 is in this confidence interval does not mean that the true value is exactly 0.3. We have no idea. Okay, so are different from the World Bank's claims. Again, we can't say that for sure because the true value might be 0.3. Who knows? Then could be the same as the World Bank's claims. And this one is true, because 0.3 is in our confidence interval, meaning that it is plausible that the true value is 0.3. Then the last one is probably are different from the World Bank's claims, and this one we will say no to as well, because given that it is in the confidence interval, I wouldn't say it's probable that the true TBD is not 0.3. So our answer is could be the same.